Well, in today's lesson, we are going to talk about Surds. What are Surds? Surds are numbers that are written inside a square root. And so, for instance, you have something like square root of 2, square root of 3, square root of 5, and so on. And so, anytime you see a number like this, then that particular number is a Surd. One might ask, why didn't I write the square root of 4? Well, square root of 4 here is equals to the square root of 2 times 2, which is equals to the square root of 2 squared, which is equals to 2. And so the square root of 2 can be simplified into a single natural number, and so we don't consider that as a surd. However, a square root of let's say a real number like the square root of 2, square root of 7, square root of let's say 5, all these ones are surds. And once they are single like this, we call them simple surds. So we have simple surds. However, if you have surds like square root of 2 plus square root of 3, they are called compound surds. Right, so a surd, a number written inside a square root, and then we have simple ones, we have compound ones. However, if that particular surd can be simplified into a natural number or any other number, then that particular square root is not a surd. All right, now in operating on surds like this, we can only add or subtract them if whatever that is inside the bracket is the same. So in this case, 2 and 3 are not the same, so we cannot add these particular two surds. However, if you're having something like this, then we have one particular square root of 3, another particular square root of 3, then we can conclude that we are adding this particular square root 1 here plus this particular one here. We are adding them together, and we are going to get 2 of the square roots of 3. So we have one of them here, we have one of them here, and we have 2 square roots of 3, provided that the one down here is equals to the one down here. Now, this is just a first thing that we should learn before we go through to check and see, okay, fine, what are some of the other ways that we can use to guide ourselves when we are solving surds. That is going to bring us to the identities. So we have identities. All right, so identity 1 is saying that what I just described. So I'm going to label it ID1. ID1 is saying that the square root of x plus the square root of x is equals to 2 of the square roots of x, provided that whatever that is inside them are the same. And so literally the square root of 3 and the square root of 3 is 2 of the square roots of 3, provided whatever that is inside the square root are the same. All of them are the same. All right, so we have identity 2 is saying that once you are having the square root of two things inside the square root, then we can multiply them to be AB, and we can also provide a square root for each of them. So identity 2, this is ID2, is saying that if you are having two particular numbers multiplying inside the square root, you can either multiply them like this or break the square root for the two of them, provided the square root is covering the two particular numbers or variables inside. And ID3, so for example, we have the square root of 2 times 3. In this case, we can say square root of 6, that's 2 times 3, or square root of 2 times square root of 3, identity 2. All right, so ID3, what if you are dividing? So ID3, identity 3 is saying that if you are dividing and the square root is covering both sides, note that this is not equals to the square root of a over b. This is a totally different thing. In this case, we have our square root covering all the numerators and the denominators. Therefore, we can rewrite this particular guy as square root of a over the square root of b. All right, ID3. Let's move on to identity 4. So in identity 4, what we are saying is that if you are if you are having ID4, ID4 is that if you are dividing by a radical or a surd like this. When I say radical, I simply made a surd like this. So we have A over square root of B. If you are dividing by a surd, it's always better to rationalize. And what do I mean by rationalize? You take the denominator and you multiply it by the whole fraction like this. So in this case, our denominator is square root of B. We are doing this so that we can remove the surd from the denominator, and it will be easier for us to simplify further. And so with this, we multiply A and then square root of B. We get square root of AB, and then square root of B times another square root of B. A number times itself is that number squared. So this, in this case, we are going to have square root of B squared, which is going to give us A square root of B over square root, and then the square will go, leaving B. And so we can see that here is simplified to this. The radical at the denominator here is gone, leaving only B. This is going to make it very easier for us to simplify and moving forward. Now, let's move further to identity 5. Identity 5 is saying that, so ID 5 is saying that if you are having a particular number, let's say A, all over B plus or minus C root D, what we should do in this case, you realize that here the denominator had only one particular number or radical. In this case, we have two terms here. Either you are adding or subtracting. What you should do in this case is to, in order to rationalize, is that take the denominator and then multiply, conjugate the denominator. So what I mean by that is that if this is only addition, you are going to multiply by B minus C square root of D all over B minus square root of C root D. This simply means that if this is addition, then here becomes negative. If here is negative, then here becomes positive. That's just all. So in this case, A will multiply the whole thing here, B minus C, the square root of B, and then these two guys will multiply. Now let's multiply and see the magic that this is going to cause. The reason why we say conjugate it before you multiply. So B will multiply B, we have B squared. Then B will multiply this guy here. We have minus BC root D, BC root D. Then this will multiply B. We have plus, because this guy is plus, this guy is negative. So plus BC root D, BC root D. Then this guy and this guy will multiply, minus, if this guy and this guy multiply, they are the same thing. So we have a square. So C root D all squared. Now, see what happens here. This and this are the same. So we have negative BC root D, then positive BC root D. They will go, giving you 0. So what is now left is A, B minus C root D all over. This is B squared, then minus this guy and this guy to go, leaving only C D. What we have done here is that we have completely rationalized, removing all the radicals in the denominator, and this is exactly what we want, so that we will be able to simplify further and then find whatever we are going to find. All right, so let's pick some examples and see how we are going to go about it.